Good morning, dear students. Welcome back. In my last class, we studied trigonometric ratios and also we compared the ratios as quotient, as co-functions and also as reciprocals. Today's class, let me recall the things what we studied in my last class and also we will take problems on trigonometric ratios. First we will write trigonometric ratios for right angle triangle. So, T ratios, let me write that as T ratios. This is very important. For that, let me take a right angle triangle ABC, right angled at B. Let me take right angle triangle ABC, right angled at B. Right. Now we will define all the 6 different T ratios to this acute angle theta. So we know that this is right angle. We call the side opposite to the acute angle as opposite side. The side opposite to right angle as hypotenuse side, and we call this as base or adjacent side. Let me write the 6 different ratios here. First one, sine of theta. In short, we can write this as O opposite by hypotenuse. It is nothing but what? AB divided by AC. To remember this, we learned a word of 9 letters, that is Osha Chota. So group 3 letters at a time. Sine is the ratio of opposite to hypotenuse. This is one group and this is the next group. Cos is the ratio of adjacent to hypotenuse. Therefore, we can write cos of theta is equal to adjacent to hypotenuse, that is adjacent divided by hypotenuse. So, which is adjacent side here? BC divided by AC. Let me write the third one, tan of theta. So, tan of theta is the ratio of opposite to adjacent. So, let me write it as opposite by adjacent. It is nothing but opposite side is AB here and adjacent side is BC. Let me write the fourth one, that is cot theta. So it is the reciprocal of tan. Yesterday we studied cot is the reciprocal of tan. Therefore, this is written as adjacent by opposite. It is nothing but BC divided by AB. Fifth one, that is secant of theta. This is reciprocal of cos. Therefore, I can write this as hypotenuse divided by adjacent. This is equal to AC divided by BC. Now, sixth one, cosecant of theta. Cosec theta. So, this is the ratio of, this is the reciprocal of sine. Therefore, I can write this as hypotenuse divided by opposite. So, this is nothing but what? AC divided by AB. These are the 6 ratios we studied in my last class. This is the first one, second one, third one, fourth, 5 and 6. So, on the base using these 6 T ratios, trigonometric ratios, let me discuss the problems on right angle triangles. Before that, here we defined T ratios for the acute angle C. Is it possible to define for this angle? Because if this is acute, then definitely this is also an acute angle, because this is sum of these T is 90. Therefore, if this is some positive number, definitely this is also less than 90. So, we can define trigonometric ratios for this angle also. We can write sin A For example, in the same figure, if I define T ratios for acute angle A, then this becomes the acute angle and this becomes right angle. Then this will act as opposite now, because the side opposite to acute angle is to be taken as opposite. ಯಾವಾಗನು ಕೆಳಗಡೆ ಇರೋದನ್ನ adjacent ತಗೋಬೇಕು ಅಂತ ಹೇಳ್ತಾ ಇಲ್ಲ. The side which is adjacent to acute angle and right angle will become adjacent. This is not the adjacent in all the cases. So we have to take the side which is adjacent to acute angle and right angle is to as adjacent. The side which is opposite to acute angle as opposite side, and the side opposite to right angle as hypotenuse. Now you define, by using the same definition you can define all 6 trigonometric ratios. Here sin A is equal to BC divided by AC, we can observe. Here we have AB by AC because we defined for C. If I define for A, then sin A will be BC by AC. So that means we have to take care of the acute angle. So now with respect to which acute angle I am defining trigonometric ratios, adana nanu careful agi nodkobeku. Because if I change the acute angle, ee eradu side enagutte interchange agutte. Right. So with this idea, let me take the problems on trigonometric ratios. The first problem in our exercise is, in triangle ABC, first problem in exercise 11.1, exercise 11.1. The first exercise, that is page number 50. In triangle ABC, right angled at B, right angled at B, AB, the length of the side AB is 24 centimeter. The length of BC is 7 centimeter. Determine first one, sin A is to be determined and cos A is to be find out. In second case, sin C is to be find out and cos C. So for the both acute angles for A and C, we need to define the trigonometric ratios. Let me write the figure which represents the given data. So here I have a right angle triangle ABC, right angled at B, and the AB is the longest side and BC is the shortest compared to AB. Then let me take like this, a shortest and one longest side. This will be the right angle B. Then this will be AB, because I need to take AB as 24 centimeter and this as 7 centimeter. We don't know about anything about side AC. Is it possible to find side AC? Yes. Being ABC is a right angle triangle, by using the Pythagoras theorem, we can find the third side of the triangle. What is the statement of the Pythagoras theorem? Pythagoras theorem states that the square of the longest side in a right angle triangle is always equal to, that is square of the hypotenuse in a right angle triangle is always equal to sum of the squares of the other two sides of the triangle. The square of the longest side is equal to sum of the squares of the other two sides of a right angle triangle. This is the statement of Pythagoras theorem. Then by using that statement, we can find the length of the third side of the triangle. Let me find it. In triangle ABC, by using Pythagoras theorem, we can write AC square as AB square plus BC square. Now, so we don't know AC square, substitute the values of AB and BC. AB is 24 square plus BC is 7 square. We need to practice the perfect squares of a number from 1 to 25. So 25 tanka kalilebeku. So we know square of 24 is 576. If you don't know, practice maadi. So if I get a new number, we can find the square of a number by using actual multiplication. So multiply 4 4s are 16, 1 remaining, 4 2s are 8 plus 1 is 9. 2 4s are 8, 2 2s are 4. So therefore this is equal to 7, 9 plus 8 is 17. 1 remaining, along with this 4 it becomes 5. Therefore I can write this as 576 plus 7 square is 49. Now I can write AC square is equal to, adding these two, 6 plus 9 is 15, 1 remaining. Now 7 plus 4 is 11, 11 plus remaining 1 enaito, it becomes 12 plus again 1 carry, so along with this 5 it becomes 6. This will be 625. We know 625 is the square of 25. Therefore AC square is 25 square. This implies I can say AC as 25. They given AB and BC in terms of centimeter, then definitely AC is also 25 centimeter. So this is the length of the third side of the given triangle. Now by using the T ratios we can define the things. The first one, in first one I need to find sine A. Now let me write AC as 25. Now we know that this is hypotenuse side, this is adjacent side. Sorry, let me erase it. So we are defining T ratios for acute angle A. If I find ratios with respect to A, let me rewrite the figure here. This is the right angle triangle, given right angle triangle, A, B, C, right angle, and this is the acute angle. This is 25, this is 24, this is 7. Now this becomes hypotenuse, this becomes adjacent because this is the side adjacent to these two angles, and this becomes opposite. Now define sine A here. What is the definition of sine A? We wrote here. What is the sine theta? Sine theta is the ratio of opposite side to hypotenuse. So I can write this as opposite by hypotenuse. Which is opposite side here? BC divided by hypotenuse is AC. This is equal to 7 divided by 25 will be the result. Next I need to find cos A. What is the definition of cos of acute angle A? You can write like this. Cos of acute angle A. So we know cos is the ratio of adjacent to hypotenuse. So adjacent to hypotenuse, that is adjacent to hypotenuse. So this is equal to AB divided by AC. It is nothing but 24 divided by 25. So these are the required result for the first problem. Now let me take one more right angle triangle with acute angle C. So I am going to take the same right angle triangle A, B, C. This is 24, this is 25, this is 7, but this is right angle. I am going to consider this is the acute angle now. If this is the acute angle, then this becomes the opposite side. Then this becomes the hypotenuse side, and this becomes the adjacent side. Now I have to define sine for this right angle triangle. So what is sine of acute angle C. I am defining the sine ratio with respect to the acute angle C. ನೋಡಿ ಆ್ಯಂಗಲ್ನ ನಾನು ಚೇಂಜ್ ಮಾಡಿದ್ರೆ ಅಕ್ಯೂಟ್ ಆ್ಯಂಗಲ್ಸು ಇಲ್ಲಿ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಏನಾಗುತ್ತೆ? ರೇಷಿಯೋ ಕೂಡ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಬಟ್ ನೋಡಿ ಆ್ಯಂಗಲ್ನ ಚೇಂಜ್ ಮಾಡ್ತಿದ್ದೀನಿ. ಚೇಂಜಿಂಗ್ ದ ಆ್ಯಂಗಲ್ ಇಸ್ ಡಿಫರೆನ್ಸ್, ವೇರಿಯಿಂಗ್ ದ ಆ್ಯಂಗಲ್ ಇಸ್ ಡಿಫರೆನ್ಸ್. ದ ವ್ಯಾಲ್ಯೂ ರಿಮೈನ್ಸ್ ಸೇಮ್. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈ ಅಕ್ಯೂಟ್ ಆ್ಯಂಗಲ್ ಇದು 30 ಇರಲಿ, ಇದನ್ನು ಚೇಂಜ್ ಮಾಡಿ 40 ಆಗಲಿ 50 ಆಗಲಿ. ಆಸ್ ಥೀಟಾ ವೇರೀಸ್ the ratio of the numbers becomes same. ಯಾಕೆಂದರೆ as theta varies these lengths are also varies. ಈಗ ಇಲ್ಲಿ 30 ಇತ್ತು ಅಂತ ಅಂದ್ಕೊಳ್ಳಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದನ್ನು ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡಿ, if I take it to 40 then definitely ಏನಾಗುತ್ತೆ? this also increases, this also increases. ಇದು ಸ್ವಲ್ಪ ಈ ಕಡೆ ಹೋಗ್ಬೇಕಲ್ವ 40 ಅಂದರೆ ಇದೇನಾಗುತ್ತೆ? this will be expanded. ಅದು ಇಲ್ಲಿಗೆ ಬಂತು ಅಂದರೆ ಈ ಲೆಂತ್ ಕೂಡ ಚೇಂಜ್ ಆಗುತ್ತೆ. as theta varies sides are also varies, but ratio of the sides becomes constant. Ratio of the sides become constant. But ನಾನು ಆ್ಯಂಗಲ್ನೇ ಚೇಂಜ್ ಮಾಡಿಬಿಟ್ರೆ, ಅಕ್ಯೂಟ್ ಆ್ಯಂಗಲ್ ಎ ಇರೋದನ್ನು ಅಕ್ಯೂಟ್ ಆ್ಯಂಗಲ್ ಸಿ ಚೇಂಜ್ ಮಾಡಿಬಿಟ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ವ್ಯಾಲ್ಯೂ ಕೂಡ ಏನಾಗುತ್ತೆ? ಚೇಂಜ್ ಆಗುತ್ತೆ. ಯು ವಿಲ್ ಗೆಟ್ ದ ಸೈನ್ ವೇರೀಸ್ ಫ್ರಮ್ -1 to +1. ಅದ್ರ ವ್ಯಾಲ್ಯೂ ಯಾವಾಗಲೂ ಕೂಡ -1 ಇಂದ +1 ಒಳಗಡೆ ಆಸೋಲೇಟ್ ಆಗ್ತಿರುತ್ತೆ ಅಂತ ಹೇಳ್ತೀವಿ. ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ ದೀಸ್ ಥಿಂಗ್ ಇನ್ ಅವರ್ ಹೈಯರ್ ಕ್ಲಾಸಸ್, ಇನ್ PUC ಕ್ಲಾಸಸಲ್ಲಿ ಕಲಿತೀವಿ. ಸೊ ನಾವು ಏನೇ ತೊಗೊಂಡ್ರು ದಿಸ್ ವಿಲ್ ಬಿ ಅ ಪ್ರಾಪರ್ ಫ್ರ್ಯಾಕ್ಷನ್ ಸೈನ್. ದ ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಬಿ ವೇರೀಸ್ ಫ್ರಮ್ -1 to +1. ಅದಕ್ಕಿಂತ ಬೇರೆ ಯಾವುದು ಬರಲ್ಲ. ಆ -1 ಇಂದ +1 ಒಳಗಡೆ ದೇರ್ ಆರ್ ಇನ್ಫೈನೈಟ್ ನಂಬರ್ಸ್, ರೈಟ್? ಆ ಇನ್ಫೈನೈಟ್ ನಂಬರಲ್ಲಿ ಯಾವ ನಂಬರ್ ಆದರೂ ಕೂಡ ನನಗೆ ಸೈನಿಗೆ ಬರ್ಬೋದು, right? So now let me define sin C here. What is sin C? Sin C is opposite by hypotenuse by using the definition. So opposite is AB here, hypotenuse AC. This is nothing but what? 24/25. Nodi value change aithe because theta is changed. Now cos C. So cos C. So what is cos C? That is adjacent divided by hypotenuse. Definition is same, adjacent by hypotenuse. Which is adjacent side here? Adjacent side is BC here, hypotenuse is AC, therefore this is equal to 7 divided by 25. These are the required solution for the first problem in the given exercise. Pause the video, write down the solution. Yes, the second problem is like this. In the figure, find tan P minus cot R. I need to define tan for the acute angle P and cot for the acute angle R, and then I need to take the difference of these two, right? For that they given the figure, they given a right angle triangle PQR, right angled at Q with PQ as 12 cm and PR is 13 cm. Now by using the Pythagoras theorem, find the value of QR. In Pythagoras, by using Pythagoras theorem, so I can write PR square as sum of the other two sides, PQ square plus QR square. PR square is 13 square, PQ square is 12 square plus QR square. So 13 square is 169 is equal to 144 plus QR square. Now take that 144 to the left hand side, it becomes 169, sign of the term changes, it becomes minus 144, that is equal to QR square. Now the difference of these two will be 9 minus 4 will be 5, 6 minus 4 is 2, 1 minus 1 is 0, that means QR square is 25. This implies 25 is the square of 5, so that can be written as QR square is equal to 5 square. This implies I can write QR is equal to 5 centimeter. Now define tan P. To write tan P, treat this as the acute angle. What is tan P? Tan is the ratio of, I wrote here, tan is the ratio of opposite to adjacent. So therefore I can write this as opposite to the adjacent. If I take P as the acute angle, which is opposite side? The side opposite to acute angle, that is QR, will become the opposite side. Which is adjacent? The side which is adjacent to right angle and acute angle. So right angle ಮತ್ತು acute angle adjacent ಇರೋದು ಯಾವುದು? That is PQ. So what is the length of QR? That is 5 divided by 12. This is the ratio. Now find cot R. Cot for the acute angle R. Now treat acute angle R as the acute angle. Then what is the ratio of cot? Cot is the ratio of adjacent to the opposite. Now cot. So which is adjacent? Now if I take this as the acute angle, then adjacent side will be QR. Adjacent side will be QR. And opposite side, opposite to acute angle will be PQ. So opposite means what? The side which is opposite to acute angle. Adjacent andre the side which is adjacent to right angle and acute angle. Hypotenuse andre the side which is opposite to right angle. Now what is QR? QR is 5, PQ is 12. Now required thing, that is tan of angle P minus cot of angle R. So this is equal to 5 by 12 minus 5 by 12. So that is nothing but what? 0. The required answer is 0. Write down the solution. Yes, the next problem is, figure is not given, they given secant theta, they given one ratio. Secant theta is 13 by 12. Then find all other trigonometric ratios. So what is given? The given secant theta is equal to 13 divided by 12. Right. Now what is the ratio of secant? Here I defined secant. Secant is hypotenuse by adjacent. Let me take a right angle triangle ABC with right angle at B and acute angle at C. Now this will become opposite, hypotenuse, adjacent. Now, so secant is the ratio of hypotenuse to adjacent. Hypotenuse to adjacent, that is AC to BC. Secant is the ratio of hypotenuse by adjacent. Here hypotenuse is AC, adjacent is BC. Now two ratios are equal. If any two ratios are equal, we can write, notice, if A is to B is equal to C is to D, this implies I can say A is equal to C times the K, B is equal to D times the K. Why? What is this K? Here K is some constant. Why we are writing like this? Because the ratios are written or expressed in simplest form. For example, if I have 2 by 4, 3 by 6, 10 by 20, 100 by 200, ಇದರಲ್ಲಿ ಯಾವುದೇ ಬರಲಿ ನಾನು ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ ಎನಿ ಆಫ್ ದಿಸ್ ರೇಷಿಯೋ ನಾವೆಲ್ಲದನ್ನು ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿ ಏನು ಮಾಡ್ತೀವಿ? ವಿಲ್ ರೈಟ್ ಆಲ್ ದೀಸ್ ಆರ್ ಈಕ್ವಲ್ ಟು 1/2 ಅಂತ ಬರೆದ್ಬಿಡ್ತೀವಿ ಸಿಂಪ್ಲಿ. ಅದು 100 by 200 ಇತ್ತಾ, 10 by 20 ಇತ್ತಾ, 3 by 6 ಇತ್ತಾ ಅಂತ ನಾನು ಮೆನ್ಷನ್ ಮಾಡಲ್ಲ ಅಲ್ವಾ? ಅದಕ್ಕೆ ಸಪ್ರೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಡೈರೆಕ್ಟಾಗಿ ಐ ಆಮ್ ನಾಟ್ ಸಪೋಸ್ ಟು ಟೇಕ್ ಎ ಸಿ ಆಸ್ 13, ಬಿ ಸಿ ಆಸ್ 12 ಅಥವಾ ಮೇಲ್ಗಡೆ 3 ಕೆಳಗಡೆ 6 ಅಂತ ನಾನು ಸಪ್ರೇಟ್ ಮಾಡಬಾರ್ದು. ಇಫ್ ಐ ಸ್ಪ್ಲಿಟ್ ದ ರೇಷಿಯೋ ವಿ ನೀಡ್ ಟು ಮಲ್ಟಿಪ್ಲೈ ಎ ಪಾಸಿಟಿವ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕೆ ಆರ್ ಎನಿ ಲೆಟರ್ ಕ್ಯಾನ್ ಬಿ ಯೂಸ್ ಟು ಡಿನೋಟ್ ದ ಕಾನ್ಸ್ಟೆಂಟ್. ಸಿ ಯೂಸ್ ಮಾಡ್ಬೋದು, ಕೆ ಯೂಸ್ ಮಾಡ್ಬೋದು, ಎಕ್ಸ್ ಯೂಸ್ ಮಾಡ್ಬೋದು, ದಟ್ ಈಸ್ ಯುವರ್ ವಿಶ್. So I wrote K, here K is the constant. It means if we split any two ratios, or we can say it is a proportion. So split ಮಾಡಿದ್ರೆ ನಾನು ಏನು ಮಾಡಬೇಕು? I need to split the values along with some constant. So this implies ನಾನು ಏನಂತ ಬರಿಬೋದು? By using this definition, I can write AC as some 13k, BC as some 12k. Right. Now in triangle ABC, I can write AC square is equal to AB square plus BC square. What is AC square? That is 13k whole square is equal to AB square. What is AB? What is AB here? So AB is, I don't know actually AB value nanu gottilla. I will write AB as it is. Nanu gottirodilli BC. So AB square plus BC square is 12k whole square. Now 169k square is equal to AB square plus 144k square. So this implies I can write 169k square minus 144k square will be AB square. So 169 minus 144, just now in previous problem find out madidvi, that is 25k square will be AB square. This implies AB will be 5 times the k. We don't know exact whether it is in centimeter or in meters because in a ratio kottirodu. So let it be unit or units. Now, so we got AB as 5k. Then AB is how much? This is 5k. This is 5k. This is BC is 12k. Then the AC will be 13k. We can memorize the Pythagoras triplets. 5, 12, 13 are Pythagorean triplets. 3, 4, 5 are also Pythagorean triplets. Some standard triplets can be memorized. Then we can reduce these number of steps. Steps na reduce madkobodu. We need to find the trigonometric ratios. I will start from sine. What is sine of theta? Opposite by hypotenuse. Which is opposite here? AB. So AB divided by AC. So AB is 5k divided by AC is 13k. So k get cancels. We will get 5 divided by 13. Second one. What is cos of the theta? The cos of the theta is adjacent to hypotenuse, that is BC by AC. BC by AC. So this is equal to, what is the length of the BC? BC is 12 times the k. This is 13 times the k. So the ratio will be 12 divided by 13. Now let me write the third one, tan of the theta, that is tan ratio with respect to the acute angle theta, that is opposite by adjacent. The opposite side is AB, adjacent side is BC. So AB is 5k, BC is 12k. The ratio will be 5 divided by 12. Fourth one, cot theta. Cot theta will be BC, reciprocal of tan. Directly we can write BC by AB, that is equal to 12 divided by 5, reciprocal of tan. Fifth one, already we defined secant. Secant is what? Hypotenuse to adjacent. 13k by 12, that is 13 by 12, same bartide. Now we can take cosecant of theta. What is cosecant? Reciprocal of sine or hypotenuse by opposite, that is AC by AB. AC by AB. AC is 13k, AB is 5k. So this is equal to 13 divided by 5 will be the result. So these are the other 5 ratios for the given right angle triangle. Write down the solution. Yes, take next 2 problems as homework. With this, we will conclude today's class. We left out with some more problems in the first exercise. Those problems can be discussed in my next class. Thank you.